All right, so this is the ungraded 2.1.5 practice worksheet in Apex. And the purpose of this worksheet is just to help you kind of understand a little further what confidence intervals and confidence levels really are. And also you're going to learn a whole bunch of really cool tricks that we can do with our graphing calculator in the process. Okay, so the first thing in here does have an introduction if you haven't read it. It says a confidence interval, I've already said this, is a range of possible values that's likely to contain the true population value. An interval is stated at a particular confidence level, such as 95%, for instance. A statistician might say, I'm 95% confident that the mean weight of these rodents is between 3.2 and 3.6 kilograms. So again, a confidence level describes how confident we are that a certain parameter is within a certain range of values. So the range of values is a confidence interval. The percentage is the confidence level. And when we're using confidence intervals, we're saying that we are this percent confident that the true population value, in this case the population mean, would be between these two boundaries here. Okay, so what does 95% confident really mean? It means that if the researcher drew many random samples of the same size from the same population and generated a confidence interval for each sample, 95% of the intervals would actually contain the parameter. In this activity, we're going to use our calculator to generate random samples from a normal distribution, then generate a confidence interval for each sample. That way you can see for yourself how many of your intervals contain the parameter. Okay, so this is going to just demonstrate how confidence intervals work. You wouldn't actually have to do a full activity like this on the exam. It's just to give you a better idea of what's going on. That's why this isn't graded. The cool thing about this activity, though, is that you will, like I said, learn a lot of cool tricks we can do with our calculator, which might be helpful later on. Okay, so the first thing that we're going to do is we're going to actually generate 20 random samples from the same population and take the mean of each sample. Now, there's a couple things about the population here that they don't really mention at the beginning. So it says we're going to generate 20 random samples, so 20 total samples. And when I come down here to actually do it, we can see they want the samples, every sample to be of size 10. Of size 50. And the population that we're taking this from is going to be normally distributed with a mean of 10. That's what I was going for, the 10. And a standard deviation of 2. Okay, so kind of no particular reason exactly why they chose those numbers here, but that's what we're going to do. We're going to pull 20 samples, each sample having 50 numbers in them, 50 values in them, and all of these samples are coming from a population that is normally distributed with a mean of 10 and a population standard deviation of 2. So to start this out, we're going to hit second list. Second. There it is, list. Stat button has the list above it. And then we move over to the math option. And I'm just following the directions right here if you lose track. So now we're going to arrow down to mean. You know what the mean is. It's going to give us an average. And I hit enter and it puts it on my main screen. So now I have to tell my calculator, what do I want the mean of? I want the mean of a random sample of size 50 from a population that is normally distributed with a mean of 10 and a standard deviation of 2. So to have my calculator do that for me, I'm going to now go to step 2, press math and arrow over to PRB, probabilities, and we're going to go down to the random norm option, option 6 on my calculator. And I'll hit enter, and then it leaves it here. On a newer calculator, it might prompt you on what to put next. So, but even without the prompts, I'm going to put in here that my normally distributed population is going to have a mean of 10, comma, a standard deviation of 2, comma, and I'm looking for a random sample from this normal population of size 50. Close my parentheses. So now you can see everything that we have in here. We're going to calculate the mean of a random sample from a normal distribution with a mean of 10 a standard deviation of 2, and our samples are going to have a size of 50. So I hit enter, and it's going to give me the mean of a random sample of 50 values from this normal population. We end up with 9.8. And if you look at the directions now, it says we're going to do this. Use your calculators, not set to do. We're going to do this 20 times because we want, like I said up here, we want 20 random samples. This is the mean of one random sample. And it gives us a spot to put these values down here. So I'll put 9.85 is my first number. Okay, and of course, if you do this same thing, because this is a random sample generated in here, your number is going to be different, guaranteed. Something's wrong if you get the same number as me, because it should be completely random. It should be close to 10 though, because 10 is the population mean. So we expect each of these to be somewhat close to our population mean. Okay, but I need 20 more of these. So now I just hit enter again, and it automatically repeats that last row for me. So I don't have to type it in again. So we're just going to keep hitting enter 20 times. So this one is 10.07. And then I hit enter again. Let it think. 10.35. And I'm just going to keep hitting enter and writing down those numbers until all of these little spaces are filled in. And again, you wouldn't have to do this whole process on like an AP exam. This is just for to help you understand what we're really doing here when we do a confidence interval. So hopefully it makes a little more sense. So I'm going to pause the video and fill this in so you don't have to watch me do it 100 times here, or 20 times really. Okay, so now I have all 20 of my sample means calculated, and you can see all of these sample means from the 20 different random samples are all very close to 10. 10, remember, is the population of the actual mean. So that's exactly what we expect to see. And again, we're just kind of we're like just obviously, you know, we're kind of simulating, that's the word I'm looking for, we're simulating taking real samples, obviously. So this is random numbers from a normal distribution that's created on our calculator, okay? But if we had actually taken 20 different samples from 50 or 20 different samples of size 50 from a true population that had these values, these are some of the means that we might end up with. All right, so the next thing we're going to do, we're going to generate an 80% confidence interval for each mean. So here's the directions on how to do that. And as it says up here, it's not really that hard, and we're going to learn some cool tricks that the calculator can do on the way. So the first thing we're going to do is we're going to put the stat button, doop, and move over to tests. We already know how to use that Z test. We're going to go down, though, to Z interval, option 7 here, and press enter. And this is what you should see on your screen. So in the next line, you have the words data and stats. We want to move over and choose the option stats because we don't actually have the individual data. We just have the statistics. And so now we go down and we're going to put in the numbers that we know. Their standard deviation of our population was 2. The X bar is a sample mean. Of course, we have 20 different sample means. So the directions say just go ahead and pick this first one, 9.85. And then for N is the the sample size, which was 50. Each of the 20 samples was of size 50. And then our C level, we want to do an 80%, not a 95%. So I'm going to change this to 0.8 for 80%. Down and calculate. And it's going to calculate for me the confidence interval. Oops, where'd it go? Hold on. All right, sorry, I had to go back to this one. This is the answer right here. So this is our 80% confidence interval for a mean of 9.85, sample size of 50. It's between 9.4875 and 10.212. So that is for the first one. So it says go back to the Z interval screen by pressing stat, arrowing over to test, arrowing down to, oh, we did that. And again, make sure stat is selected. We're going to change to the second sample mean. and repeat the process 18 times to find all the intervals for your sample means. So give us somewhere to write these ones down. Oh, it does. There it is. That's what I'm looking for. So this first interval for the first sample mean gives us an interval between 9.5 and 10.2. It's kind of hard to write that in there. 10.2. I don't want to just write the whole numbers. Maybe I gotta zoom in here maybe. All right, so we're gonna do that again for the next number, which I'll have to scroll up and find my next sample mean, which is 10.07. So I'll go back to stat, over to tests, option 7, Z interval. And all I have to change here is my X bar. I'm going to change it to my next X bar, which is 10.07. And calculate. There's my next one. So I'll come back over here and write that one down, 9.7 to 10.4. Okay, and I'm going to keep repeating this process until I get all of these filled in, one for each sample mean. All right, so that process took a little while. You should be glad that I went ahead and pause that. But these are the intervals that I came up with. And so the next thing we're going to do is we're going to look at how many of these intervals contain the true population mean. Remember, the true population mean was exactly 10. So if I go through these, most of them do contain 10. I'm just going to highlight the ones that do. And if 10's in the border, then it's not necessarily included. So I'm just going to go ahead and highlight the ones that do. It's like most of them. And yours might be, yours should be slightly different. Because again, these are random. So that's what I end up with. It's 1, 2, 3, 7, 9, 11, 12, 13, 14, 15 out of 20. 15 out of 20, which is about 75%. Nope, I missed one. Oh, no, I didn't miss one. I need to go back and look at some of these decimals to figure out if they actually truly include 10 or not. But the point is, if I take the number that I got, or the number that you got that does contain 10, and divide it by 20, because there's 20 total samples, you should have got something close to 80%, because you chose in your calculator to get an 80% confidence level. It says if your final number is closer to 90 or 70%.
Teachers at this time, please leave students writing bus numbers.
Okay, so it says if your number's not within 0.1 of 0.8, so if it's 0.9 or 0.7 or even further from that, then you might have some incorrect numbers in your calculator. I got 0.75, which is closer than that to 0.8. So I think we did okay. Again, these numbers are all random, so there's going to be a little bit of variation in there, but that's pretty close. So that's kind of the process of what finding a confidence interval really means, okay? And so hopefully this gave you a better idea of what confidence intervals are. And if you want to, you can try this process again, like they say here, but that's, I mean, as you can see, it's a long process. So let me know if you have questions.